Thank you. So we call it bits when it gets to what do you call it? Layer one. When it gets to layer one, we refer to our data as bits. Now, don't forget, I'm using layer one, layer two, layer three, and all of these to refer to OSI model layers. Now, I need to tell you guys something before I move on. All of these things we are talking about is just like you want to send letter. The message, you carry a sheet of paper, you get a pen, you write the message. The sheet of paper is not the message. Even the ink in the pen is not the message. But you write the message on the paper. So if I happen to read the message now, I can get rid of the sheet of paper. I've gotten the message. So the sheet of paper is not the message. The pen is not the message. And when you are done writing this letter, you fold it. You get an envelope. You put the letter in the envelope. You seal the envelope. You write from on one side. You write to on the other side. You get stamp from post office, and then you go to post office. You go to post office. You get stamp and post. All of these things you have done is just to help the data or your message to be conveyed from source to destination. So when we say your message or your data becomes segment, some things are added so that it can help that data to move from source to destination. When it gets to layer 3, some other things are added so that the message can move from source to destination. When it gets to data link layer, some other things are added. And the reason why everything is now converted to zeros and one is because computers don't talk our language, they speak in binary. That is just a summary of OSI model or TCP/IP model. Things are added to enable our data to move from source to destination. So that is just a summary. So let's move and begin to explore the layers one after the other. So if I get to an environment where I know that I've explained this, then I will just keep and move on. Now, don't ever forget this. OSI model, you should be able to tell me all the layers by heart. TCP/IP model, you should be able to tell me all the layers by heart. So look at where the journey started from. The journey started from application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So if you are sending data, you reside at the application layer. The journey will start from the application layer, going down. And that is why we call the process of encapsulation. Encapsulation. Now, also you need to know the layers that we have under TCP/IP model. We have application layer, we have transport layer, we have internet layer, and we have network access layer. And don't ever forget the layers that were bundled together, that is in OSI model, that gave birth to the one we have in TCP/IP. Don't forget transport is still transport. And for network layer, they changed the name to internet layer. And they also bundle two layers together, two lower layers of the OSI model, to give us what we call network access layer. So what do you need to know? You must know the differences between the two, and you must know the similarities. And you should be able to compare them. This is very important. So let me read what I have here. The OSI model divides the network access layer, the network access layer and the application of the TCP/IP into multiple layers. That is OSI model. It divides the network access layer. Which one is the network access layer? This is this layer here. Now, we are using the two. Why is this thing always moving now? We are using the two combined now. We are saying the OSI model divide the network layer, the network access layer, and the application layer of the TCP/IP into multiple layers. So it means if I'm talking about network access layer, I'm referring to two layers here. If I'm talking about the application layer of the TCP/IP model, I am referring to three different layers of the OSI model. You should be able to understand and compare the two. Now, the TCP/IP protocol suite, I talked about protocol suite in the last class, does not specify which protocol to use when transmitting over physical medium. OSI layers 1 and 2. You see now? We're beginning to mention numbers now. Layer 1, layer 2. Discuss the necessary procedures to access the media and the physical means to send data over the network. So it simply means anytime I want to talk about the physical connection, whether it is wired, whether it is wireless, whether it is fiber optics, whatever I'm using, I know that all my discussion resides at layer 1. If I want to talk about the technology that enables us to build local area network or that enables us to build wide area network, these are called procedures or protocols or technology. We call them LAN technology or WAN technology. I know that all that discussion, they all reside at layer 2. And you're going to see these things as we move on. So the first is physical layer. So why are they taking it from the bottom? That's what they decided. Physical layer is our layer 1. They're taking it from the bottom. So what happens at physical layer? Of course, you know it has to do with physical connection. I just summarized that one now. Now look at what they said. Before any network communication can occur, a physical connection to a local network must be established. This connection could be wired or wireless, depending on the setup of the network. This generally applies whether you are considering a corporate office or a home office. So there must be physical connection. And when we say physical connection, we don't mean something you must see a cable. No, even the wireless is physical connection. And don't forget, we already said that in the class that the wireless uses electromagnetic wave. We also need what is called a network interface card to connect to the network. You have wired network interface card where you can plug your cable physically, and you also have wireless network card. That's why your tablet can connect to the wireless network without any cable in between because there is a card in that device. Your phone also can connect to the telecom equipment or infrastructure because there is a wireless card in that your phone. Some devices may have just one NIC, that is one network interface card, while others may have multiple NIC, one for wired and wireless. For example, like laptops generally used to have, they have they have at least minimum of two cards. You have one for physical connection and you have one for logical connection, or I call it spiritual connection sometimes because you don't see the connection. You just know that you have access to the wireless network. Now listen to this. This is very important. Not all physical connection offer the same level of performance. Sometimes, I don't know in Europe, especially in our environment here, you connect to the wireless network, maybe in your school or wherever, the network is slow. But you carry that same computer, go and plug to the physical, use a cable to connect. You see that the network is fast. Why? Because if you build a wireless network and you don't do it the right way, it will have some level of poor performance. So you need to be sure what you are doing for you to be able to build an optimal wireless network that people will connect to and will not be able to complain. So somehow physical wireless network, most of the time people have issues, but for physical cable, that is when you use physical cable, people don't really have problem with that. So this is what we are trying to say when we talk about layer 1 and layer 2. Now, look at what they said about physical layer. Anything that has to do with physical things like your cable, your network card, and whatever, the physical layer standard, that is our layer 1, are implemented in hardware, physical things, and are governed by many organizations, including we have the ISO, we have the EIA/TIA, ITU-T, ANSI, and IEEE. These are the people behind the standard. Meaning what? They define what is going to happen at layer 1. They define what you need to put in place for things for the cables at layer 1 to work properly. They define a lot of stuff. Our own is we just go to market, buy the network cable. The people that manufacture the network cable, they must have followed some things. They must have followed some standard before that cable can be used. It's like a what do you call it? A framework. It's like a framework. You follow it, you put it in, just follow it. Or what some people call prototype. You follow it, and by the time you are done manufacturing your cable, everything will be intact. So those are the people behind the standard. So what do we need to know about physical layer standard? They address three areas majorly. They talk about the physical components, and this is not for us, mainly for the manufacturers. They talk about the physical component, what are the things that need to be in place. They talk about the encoding. I mentioned encoding in one of the classes where I said it's just a way of representing our data on the wire. And then the signaling. The signaling is all not very far from encoding. It's just a way of representing the data on the wire, but somehow you use wave, high, low, zeros, and ones, and all of that. So all of these standards are must be observed by the manufacturers of most of these physical things we use on the network. And when I say physical things, I mean things that resides at layer one, like your cables, like your maybe network card, and so on and so forth. So the physical component are the hardware devices, media, and other connectors that transmit the signals that represent the bits. You see that? So hardware component like NIC, that's network interface card, interfaces, that's on the devices like in the switch or in the router, connectors, cable materials, and cable designs are all specified in standards associated with physical layer. So there's a standard, and those people must follow these standards to get the job done. If they don't follow the standard, there is going to be a problem. Like what? For instance, there are some network cable you buy. If you use the cable to network, you send data. Maybe you send Faith want to send $100, as in transfer $100 over the cable to Inkechi. Before it gets to Inkechi, $10 don't drop. I mean the signal strength. So by the time the message gets to destination, it cannot be read properly. Why? Because if the cable is a bad cable. When I say bad cable, it simply means they didn't follow the standard. And when we want to do when we want to do anything in the field, we make sure that layer one is intact. Because if the layer one is not intact, it does not matter what you build on top of it, you are going to have problem. So our layer one cabling in particular to network or the access points that transmit people will connect to, things must be in place. It's like the foundation of your network when you are building the network. That is why when you hear people say they are upgrading the network, the first thing they will go and dismantle on the network is the cable. Maybe the cable, not because the cable is bad, maybe there is a new standard with a new speed, with new quality and all of that. They can get rid of the old one and get a new set of cables that can transmit data faster than the other one that they used to have on the network. So these are things that have to do with layer ones. We don't really have plenty business with layer one as such, but we cannot leave it behind. We still need to talk about things that are happening at layer one. But what we need to know majorly at layer one, that is where our data is converted to zeros and ones. Layer one has to do with physical components like our network card, like our connectors and stuff like that. And most of the time, when we get to troubleshooting, that is trying to fix a problem on the network, I can tell you that okay, there are different ways to troubleshoot on the network. We have what we call bottom-up troubleshooting, that is starting from layer 1 to layer 7, or we have top-down troubleshooting, starting from layer 7 down, or we have divide and conquer. So if I'm teaching you guys now, bottom-up, meaning we're starting from layer 1, I will just say you start from your network cable. So if you are called, oh, Faith, I can't browse, and you want to troubleshoot, if you don't have experience, you want to do bottom up, meaning you check the physical layer first. What's at the physical layer? The network cable. Is there any problem with the network cable? Is it properly connected to the computer or to the switch? So this thing we're talking about, we will still make use of it when we come to troubleshooting. We'll make use of it when we come to cyber security. We make use of it every time. It's like it guides us like a framework or a guideline to do so many things. Like when it comes to attacks can come in at layer 3, attacks can come in at layer 4, attacks can come in at layer 7. So many things are joined together to all these models we are talking about. That is why I take my time to talk about the OSI model. Okay, so that's that about the physical layer. So the next layer is data link layer. Data link layer, don't forget what our data becomes our data link layer. We call our data frame. It is still data, but something has been added to that data. That is why we call it frame. So let's check how what is added to our data. Why we call the data frame at layer 2 and the things happening at layer 2. So what is data link layer responsible for? The data link layer is responsible for communication between end devices, network interface card. You are not the only one there. You are not the only one responsible for that. So can you tell us more about yourself? It allows upper layer protocols. So which protocols are upper layer protocols? I'm coming there. To access the physical layer media. Okay. And look at what we are going to. And encapsulate layer 3 packets. Remember I said the data becomes packet at layer 3 into layer 2 frame. Okay. So the data link layer encapsulate layer 3 packet into layer 2 frame. Can you tell us more? It also performs error detection and reject correct frames. Okay. Let's break it down further. What exactly are the things that we can point to, or the major thing, the most important thing we can point to, the change that we can point to that will happen at layer 2? We know that identity of our data will change from packet to frame. Okay, but this frame, what happens? Why are we calling the data frame? Guess what happened there? The computer has a network card, the source computers and the destination computer. They both have network cards. And this network card has what we call MAC address. The network card on my computer has a MAC address. The network card on your computer has a MAC address. And these MAC addresses are referred to as layer 2 addresses. So anytime I'm talking, I mention MAC address, you just know that I'm referring to layer 2. MAC address resides at layer 2. So what happens at layer 2? The source MAC address of the sender and the destination MAC address of the receiver are both added to that data. So it simply means layer 2 will look at the message and say, okay, you are coming from this MAC address and you are going to this MAC address. And that is what you see in this place now. Source NIC, destination NIC, or what you call a layer 2 address. So when you hear talk about MAC address, it's a layer 2 address. So what happens on layer 2? Source MAC address will be added to my data. Destination MAC address will also be added. Where you are coming from and where you are going to. And layer 2 has no business with IP address. That is the major thing that happens at layer 2. So when you hear us talking about layer 2 header, it's just additional message added where we can insert the source MAC address and this destination MAC address, so that when the message gets to the destination, they know where you're coming from and where you're going to. They know the layer 2 address of the sender and they know the layer 2 address of the receiver. That is what happens at layer 2. Just a minute, please. Sorry, please. I went out this morning. I think code entered me.
Sorry.
My wife said I cannot live in Europe if I'm having cold in Josh. How will I survive
Yeah,
in Europe?
you're always having cold. And
Faith, Faith just finished me.
no cold, but that's true.
You know, there was a time I didn't have cold for a long time until recently the thing started again.
Wow.
So I don't know why my system doesn't like code at all. If you see the way
Your
I'm
body
dressed,
was.
if you see the way I'm dressed now, you think I'm in Sweden. You say Sweden is very cold.
The good thing about it is that even if you come, your body system will adjust.
So I will tell my wife that too, so I can live in Europe too. Okay. So at layer two, source MAC address is added, destination MAC address is added, and my data is called frame. Not because it's not data, it's still the data. My data is still there. Other things needed to help it to get to destination are just been added at each of these layers. Okay. So what about the error detection and reject frame? Now, end to end, if there is any error during the transmission, layer 2 is the one that will help us to detect the error. Meaning what? If I'm saying I'm sending you $1,000 and you got $999, that means that message is not completed. Layer 2 can do what we call error detection. It now tells us, it's like, okay, and I think a better example would be you downloaded something from the internet and you are trying to open it and it's telling you that it's corrupted. That is something that is not completed. The message is not completed. So, but majorly, what happens at data link layer, the source MAC address of our computer is added, and the destination MAC where it's going to is also added. Do you people know how to find the MAC address of computer?
Yes.
I think I showed you in the last class or the first day.
And you showed us from the
From the
command
command prompt,
prompts.
yes. Okay, good,
Yeah,
good, good, good. Okay,
I
Nkechi
don't know
said
if you
no.
can choose.
Nkechi said no, so let's just do it. So if I
So I
want,
think another way for Ikechi to know the layers, I have an acronym for it.
okay, good.
No, I will share it with her.
Okay, good. So let me share my command prompt and just show you straight away. So ipconfig slash all. Can you see my command prompt? ipconfig slash all. Now, I have more than one network card. Now you can see this is the wireless card that I'm using because I'm connected to my phone. So I'm going to see the details about my wireless card. If there are other cards and I want to see the details about those cards, I will go and see the details. But let's just check out my wireless card here. So now you can see it's going to give me some message about the card, description of the card. It's an Intel card, dual band, wireless, and all of that. But next to it, you're going to see physical address. Look at it here. Physical address. So my MAC address is OC 8B FD B6 6181. So if I'm sending anything to you, if you capture that packet or that data on the way to destination and pieces it, then you are going to find a layer 2 header. In that header, you will see this MAC address there because I am the sender. And wherever it is going to, it's going to put the destination MAC address of the receiver. So this is my MAC address. Ikechil, is it clear?
Yes, sir.
Okay, so layer 2 is the one taking care of this. So if I want to refer to MAC address, I can say layer 2 address. I can say physical address. I can say MAC address. I am still saying the same thing. Layer 2 address, physical address, or MAC address. I am still saying the same thing. So when we call our data frame, it's layer 2 that is doing this job. It's adding the source MAC address and also adding the destination MAC address. Now, we need to take this thing further. We need to take it further. IEEE 802 LAN/MAN data links of layers. What do they mean by this? Inside that data link layer, we can pieces that data link layer into two. And that is what we call sub layers. One is LLC, the other one is MAC sub layer. So if I just say data link now, inside that data link layer, there are two sub layers there. LLC and MAC sub layer. This is logical link control. Look at it here. and media access control. So what is the job of these two layers? No big deal. Look at it here. The LLC sublayers communicate between the networking softwares and the upper layers, and the device hardwares at the lower layers. What does that mean? For my data link to begin to communicate with layer 3 and above, it uses the LLC. For my data link to communicate with the lower layers, what I mean by lower layer is only physical layer that is lower. It will use the MAC sublayer to talk to physical layer. Why? When you want to talk to upper layers, now upper layers are from layer 3 and above, and lower layer is layer 1 and 2. So we refer to layer 1 and 2 as lower layers, and from layer 3 and above, we call them upper layers. So for my data link layer to talk to upper layers, it will use this sublayer, this LLC, to communicate with upper layers. But if it has things to say or to transmit to lower layers, it will use the MAC sublayers to talk to lower layers. And this is just what we need to know as far as these sublayers is concerned. So anything going on at physical layer, my MAC sublayer is the one talking to them or transmitting to them, things to them. So therefore means some of the technology we are going to be talking about in the future, they reside or they happen. These things happens at, even though we say they are at layer 2, but it's not the whole of layer 2. Look at it. For instance, now if I want to talk about Ethernet, it's a LAN technology. I can barely point it at MAC sublayer. Or wireless LAN, MAC sublayers. Wireless PAN, MAC sublayers, and so on and so. So part of our technology, what we call LAN technology or WAN technology, that we used to say they operate at layer 1 and layer 2. They don't consume the whole of layer 2. They only took a certain part of layer 2. And I'm going to explain further when we get to those part of those topics that have to do with these things. So just know that your data link layer has two sublayers. One is MAC, one is LLC. LLC is used to talk to upper layers, and MAC sublayer is used to talk to lower layers. And when we get to where we need to expatiate further on all of these things that are here, I'm going to talk on those first. So that frame, what do we have in the frame? What do we have in the frame? It has three parts. So my frame has three parts. One is called the header, where you have the source MAC address and the destination MAC address. The other part is the data itself, which is the real message you are sending. And the last thing is the trailer. What is in the trailer? That is the information it is going to be using to detect error or to report error, and so on and so forth. So look at what he said here. Data is encapsulated by the data link layer with a header and a trailer to form a frame. So my data is already there. The layer 2 header is added and a trailer is added at layer 2. So we call that data frame, and you know who is in charge of that. The amount of control information carried within the frame varies according to access control information and logical topology. Now, I won't want to go into this for now. We'll come to some other technology. We're going to be talking about that. Okay, so this is, if we capture the data right now with Wiresharks, we are going to make use of Wiresharks later, especially in cybersecurity. This is the way you are going to see it. So our header is added, we have the real data, and then we have the trailer. Okay, so what do we have in the header? We have start frame, we have addressing, we have type, we have control. These are things needed for the layer 2 to do its job, and this is where our attention should be on the addressing. That is where we have the source the source MAC address and the destination MAC address. What about the trailer? That's where we have the error detection and the frame stop. Let's talk about the beginning of the frame and the head of the frame. You need to be aware of this. Any question? I will see if I can finish this slide. If I cannot, we'll move it to another class, but I will try to finish it, and I don't want to rush anything. Okay, if you guys don't have questions, then I can continue. So we're still talking about frame. Frame. It's a layer 2 issue. It's a layer 2 thing, okay? So there's another device we also need to talk about that also operates at layer 2. We've mentioned MAC address is a layer 2 thing. MAC address is a layer 2 thing. So now what is Ethernet frame? Ethernet. Now take note, this is not internet too. This is Ethernet. Ethernet frame. Ethernet. So don't confuse internet with Ethernet. They are two different things. Ethernet is a LAN technology. Meaning, whenever you want to build your local area network, the cable is based on Ethernet technology. The switch is based on Ethernet technology. The access point is based on Ethernet technology. And what do I mean by that? In those days, there are different ways of building your local area network. They have what is called Ethernet, they had what is called token ring, and then they had what is called FDDI. It's just a way of building your local area network. But the token ring died, the FDDI also died, we are left with only Ethernet. So if I'm building a local area network right now, just drop a switch and connect computers to it. Oh, my switch is based on that Ethernet technology. It's just access method. If I connect computers to this switch, how will they talk to themselves? They can send simultaneously. That is how Ethernet operates. But on that token ring, only one person can send at a time. It's like when you have when you are running a race, until you get the baton, you cannot take over. You cannot move. So Ethernet is a technology, and we call it a LAN technology. So the frame on our network we can also refer to as Ethernet frame. And this Ethernet that I'm also calling LAN technology also operates at layer 2. So let's see what they have to say here. Ethernet operates in the data link layer and the physical layer. It is a family of networking technology. You see it there, right? It is a family of networking technology defined in the IEEE 802.2 and 802.3. So you can see what we have in this place right now. Ethernet is a technology that enables us to build our local area network. And the people that came up with this technology, they were the one that gave us, oh yeah, just buy a switch, buy a cable, connect them directly, and they will work. We just need to know about the access method. If we do that, how will our devices talk to themselves? They talk directly, and they can talk simultaneously, and there will be no issue. Now, I'll still talk about Ethernet in another, I think we have another chapter dedicated to that. So why are they telling us about Ethernet? Because we are talking about layer 2. We need to know that this technology, LAN technology, also operates at layer 2. So the frame we are talking about is based on Ethernet technology. So the technology itself, which is the Ethernet, operates at layer 2. And when we talk about frame, we are at layer 2. So these are things you need to be aware of. Now, what are the things they are now trying to tell you? They are trying to tell you, okay, for a minimum Ethernet frame, meaning a frame on an Ethernet network, the size should be 64 bytes and maximum of 1518. What is the meaning of all of this? Now, these things are relevant in the days when they used to have collision. But nowadays, they are no longer relevant because we don't used to have collisions again. And I don't want to go into the details of that right now because we are still going to talk about collision and collision domain. Because if your data is caught up in the collision, by the time it gets to the wire, it will not be up to 64 bits. And because of that, it will be discarded. It will be discarded. So we are going to talk more on collision domain and broadcast domain and all of that. But what you just need to know about Ethernet is this is a layer 2 issue. It operates at layer 2 and so on and so forth. Okay? Then look at what they are saying here again. MAC address is a layer 2 thing. Now they are saying Ethernet MAC address. Why? Because the computer that is operating we connected to the network is also on Ethernet network based on Ethernet technology. So if you like, we can decide to just yank up that Ethernet and just be calling and just say MAC address. But we all know MAC address is a layer 2 thing. And we also know that MAC address is bought into a computer, and all of these details we know about MAC addresses and stuff like that. So what do we need to know about MAC address? I have shown you the MAC address, but you need to know something about MAC address. Number one, you need to know that it's a 48-bit binary value, and it is represented in form of hexadecimal, 12 hexadecimal values. If you can't, let's go back. Let me show you that MAC address again. Can you still see my command prompt? Faith, can you see the command prompt? Okay, let me share. I think I didn't share. What about now?
Yes, sir.
Okay, good. So if we say the MAC address is 12 hexadecimal, look at O, that is 1 hexadecimal digits. And if you convert that into binary, you get 4 bits. C is another one. So if you count this all together, this is OC, HB, FD, that is 6 already. B8, 61, A1, that makes it 12. So your MAC address is always 12 hexadecimal values or digits. So if you convert the hexadecimal values into binary, we are going to get 48 binary values. Okay, so you need to be aware of that. And how do you know that it's a binary? Anywhere you see OX, that is binary. So you need to know this about MAC address. It's a 48-bit binary value, and it's 12 hexadecimal values. Another thing you need to know about your MAC address. The first 24 bits represent the manufacturer of the network card. The first 24 bits, which is the first 12 hexadecimal, let's say 12. The first 6 rather, that is the first 6 hexadecimal digits will represent what we call the OUI, Organizational Unique Identifier. And the last 24 bits will represent the one that belongs to your computer specifically. So it means if you bought a card now and the card is from HP, if you get a network card that is from HP, this part of that card, of those cards, now if you take, let's say you have 1,000 cards from HP, the first 24 bits will be the same, but the remaining 24 bits will be different. So that is to tell you your MAC address can be divided into 2 portions. One part represents the manufacturer. The other one is the one that the vendor assigned to that particular computer. And you cannot have 2 computers with the same MAC addresses. It's not possible in the whole world. MAC address must be unique to every computer. It's very important. So that is just a summary of what I have in this slide. Okay, so I've explained this part. What happens when you send something from source to destination? Your source MAC address must be added and destination MAC address is added. What if I don't have your MAC address, but I have your IP address? That is what will take us to what is called address resolution protocol. We're going to talk about HAP, and I'm going to demonstrate that for you people through Packet Tracer. So we're also going to take care of that. So let's not waste time here. So you can have a unicast MAC address. What does that mean? one MAC address trying to talk, one computer trying to talk to another computer. That is called a unicast. So if I have your MAC address and I want to send message to you, your MAC address is unicast. But sometimes you can always also have a MAC address that I can. There's also a MAC address that I can use to send to everybody on the network. For instance, now if I want to send a message, which we call broadcast, to everybody on the network, what will be my destination MAC address? That one is going to be called a broadcast MAC address. So unicast is a one-to-one thing, while broadcast is one to all, one to everybody on the network. Like that app that I'm talking about. If I want to send a message to you, I have your IP address, but I don't know your MAC address. I will send the message to the broadcast address, which is FFF. I think F is in 12 places. So when the switch gets the message and see that this is a message for everybody, it will replicate the message and forward to everybody on the network. So that's a broadcast. So unicast MAC address is one-to-one, and broadcast MAC address is one to everybody on the network. And this is what you can see in this place now. F, then FFF. That is a broadcast MAC address. So it simply means I want to talk to somebody. Let's say I want to send a message to Faith. I have your IP address, but I don't have your MAC address. So what will I do? I will say, hello, everybody. I have a message for the owner of this IP address. Please, could you please send me your MAC address? So that message will be flooded to everybody on the network, and whoever is the owner of the IP address will respond back with a unicast. So, okay, I am the owner of this IP address. Here is my MAC address. I will send to a broadcast MAC address, and then you respond back to me through a unicast address, MAC address. So with that, I can now forward the message to you. And all of this is, we're still at layer 2. We have not entered layer 3. Also, we can have what is called a multicast MAC address. So what is multicast MAC address? Unicast is one-to-one. Broadcast is one-to-all. But multicast is one to set of people, set of computers, or set of devices. For instance, your switches on your network or your routers on the network, they use multicast IP address in this scenario now to talk to themselves. So we can also, in the same way we have unicast MAC address, we can also have multicast MAC address, which is just to a set of, not to everybody. You can see an example in this place right now. This computer wants to send a message to a group of people. All these computers you see here, they all can respond to this particular MAC address. That is called multicast MAC address. It's like you group people together, and then you forward a message to that MAC address, and the switch knows that that message, all these people can get the IP, they can get the message with that particular MAC address, and that is called a multicast MAC address. And this is still a layer 2 issue. So my router can fall into this, and the switch also can use multicast MAC address. We can also have application on the network that can also use multicast MAC address. That is just a summary of what you need to pick from this particular place. So what about MAC address table? In the last class, I demonstrated MAC address table to you people. So MAC address table is what the switch will gather together. When computers are connected to the switch, the moment you send a message, it knows you are there. You put your MAC address in that particular table. It builds a MAC address table so that when people want to send to themselves, it knows where people are located. It does not need to forward them, to broadcast the message to people on the network. So I've talked about that one. So switch also is called a layer 2 device. Your bridge is a layer 2 device. I didn't mention that when I was talking about those devices. Your hub and your repeater are called layer 1 devices because they cannot make decision. The hub and repeaters are called layer 1 devices. But your bridge and your switch are called layer 2 devices, while your router is called a layer 3 device. And we're going to see why. So why is it that they call switch a layer 2 device? Because Switch does not bother about MAC address, about IP address to make decision. It has no business with IP address. It only concerned about MAC address to make decision. So that's one of the reasons why they call it switch a layer 2 device, because it has business with MAC address. Your bridge also will do the same thing. It has business with MAC address. It will use the MAC address to make decision. That's why these devices are called layer 2 devices. And it can only have your MAC address in the table where you send message. And switches also learn and forward. I explained that also. They learn the MAC addresses and then they can begin to forward message. If they don't have your MAC address in the MAC address table and the switch has a message for you, it's going to broadcast it. Hello, I have a message for somebody like this. If you are the owner, please carry the message. It's going to broadcast that message. We'll talk more about switch. Okay, I think it's Faith has gone. Okay, so we'll talk more about switch in another when we come to some part of configuration. So you can learn and you can forward messages based on MAC addresses in the MAC address table, or you can also broadcast, or you can also send a multicast message. So when you say the switch can filter frame, it simply means when you get a message made for somebody, it checks in MAC address table. Once it sees where you are located, it pushes the message to you. That is what it means to say a switch can filter frame and forward the message through a single port. All right, so that's all I want to say about layer 2. Ikechi, you are left with me alone here. Do you have any question? Just a minute.
No questions, sir.
Okay, so are you flowing?
Yeah, I'm flowing up. Flowing.
All right. So the videos I said, have you gone to the videos again? Those 6 videos I said you guys should listen to.
Yes, they are better now after the last class.
Good. So after today's class again, you go through them again.
Okay, sir.
And this probably will be the last time I will say you should go through them again. Okay, so let's continue. The next layer we want to talk about is network layer. So what happens at network layer? Don't forget, at network layer, I said we call our data packets. We call data packet at network layer. Okay, so let's see what happens here. Look at what it said here. Addressing end devices, encapsulation, routing, and the encapsulation. These are the things that happens at layer 3. That doesn't mean that encapsulation did not happen at layer 2 or layer 4. We also have encapsulation there. But the main thing that happens at layer 4 is the addressing end devices. What do we mean by that? The moment you assign IP address to your computer, to your router, or to your switch, you are basically activating with a protocol called IP. And that protocol resides at layer 3. So the computers don't come with IP addresses by default like MAC addresses. So if I'm sending a message to you right now, that message at layer 3, something needs to happen to that message. The source IP address, which is the IP address of the sender, must be added to that message. And the destination IP address of the receiver must also be added to that message. And that takes place at layer 3. So network layer is in charge of adding the source IP address and destination IP address. So it therefore means it's not only MAC address that will be added to the message traveling. The IP address also will be added. So the IP address is referred to as layer 3 address. And we are the one to assign the IP address to our computer. So let's go. Let's move on. So look at what they are saying here. They said the last layer 3 now. IP encapsulates the transport layer segment. That is, I told you the journey will start from layer 7. 7 to 6 to 5 to 4 and then to 3. And don't forget, at this 4, our message is called segment. So this segment will be encapsulated into what is now going to become what is called a packet. So what happens to our data layer 3? The source IP address is added, destination IP address is added. So where are they going to be inserted? It is in something called IP header. And this is also called a layer 3 header. So why do we need that? If we don't have that, the message cannot travel from source to destination, because all of this is need to be completed. Source MAC address needs to be there. Destination MAC address needs to be there. Source IP address needs to be there. Destination MAC address, IP address needs to be in the message before the message can travel from source to destination. And layer 3 is the one in charge of this. So my message or my data is converted or encapsulated, that's the right word, from segments to packets. And thereby, I will go to have IP header will be added to the data. And in the IP header, we are going to have the source IP address and destination IP address added to my message. Well, look at what they say here. What is that? We are going to do that. A whole chapter dedicated to that. That we change the addressing, but we'll be discussing the later module. So let's leave that for now. But this is crucial. Look at this here. The IP addressing does not change from source to destination. What is the meaning of that? If we put on the packet or insert on the packet that this is for B and it's going to Nkechi, it does not matter how many routers that message pass through. The source IP address and destination IP address will not change. So what will be happening on the road? Each of the routers will be collecting the message. Where are you coming from? Where are you going to? I'm coming from Roland, I'm going to Nkechi. They pass it to the next router. I'm coming from Roland, I'm going to Nkechi. They pass it to the next router, and so on and so on. So the source IP address will never change, and the destination IP address will never change from source to destination. And that is very important for you to understand. Because when you want to write certification, some questions they will give you, they are theoretical, like what I just mentioned right now. They are not going to, some questions, they are not going to tell you to configure router or switch. In some people that have written certification recently, they didn't configure anything, only theoretical from beginning to the end. And these are some things you come across. And we're going to deliberate more when we do some practicals. So at layer 3, my message is called packet. IP header is added. So what is in the IP added? Header, source IP address, and destination IP address. That is in my header. Or those are the things I have in my header. Now look at this. This is also important for theory. IP is meant to have low overhead and may be described as connectionless. Best effort. Median independent. What is the meaning of this? What is the meaning of this? I will just explain that so that we can cover a lot. Now, when you are sending a message from source to destination, let's say this is PCA and this is PCB. I want to send a message to destination. All these layers we have been talking about, they will do what they are supposed to do. But they are telling us there's something we are going to have to point to. Anytime you hear TCP IP, TCP IP, we're going to talk more about IP and TCP. Some people put it this way, and I think I like that. This TCP will carry the message to the destination. It's a transporter, it's a vehicle. But the IP points the way, the road to the destination. IP points the road to the destination. TCP carry the message from source to destination. So they work together. You are the carrier, I'm the one showing the road. You are the driver, I'm the one pointing the road to you. So they're telling us something here that is very important. They said IP is connectionless, meaning what? He does not need end-to-end connection before he can show you where we are going to. It's going to be showing you the road pattern. Okay, this is the turn right, the turn left, then turn right, then turn left. It does not show you from source to destination, all the way from just to London. No, it's destination per destination until we arrive at London. But TCP, the way it works, is connection oriented, meaning it must have end-to-end connection from source to destination. Logically, all these are happening simultaneously. So it will now be relying on IP to be seeing the direction. Turn right, turn left, turn right, turn left, and so on and so forth. So when we say IP is connectionless, it doesn't need to have end-to-end connection. It does not have any business with end-to-end connection. It just needs to show you the road, and TCP carries the message to the destination. We're going to come to TCP later. Now, IP is also best effort. Best effort is, I've done my part. I wish you all the best. Whereas when we come to TCP, you will see the features of TCP. TCP doesn't work like IP. TCP wants to make sure that the job is done well. If I say I'm sending $1,000, in Nkechi, I have sent you $1,000. TCP wants to be sure that you got the $1,000. But IP does not care. It doesn't care whether you get the money or you didn't get the money. So when we say IP is best effort, it will do whatever it can do and leave the rest to TCP to handle. And then when we say IP is media independent, it simply means IP can operate on wired, wireless, fiber, whatever. He doesn't care the media you are using. It doesn't care. As long as you are able to establish connection, IP will do what it's supposed to do. That is the summary of all this. IP is connectionless, IP has best effort, and IP is media independence. Is it clear, please?
About connectionless.
Connectionless. We don't need to have
TCP,
end-to-end connection from source to destination. We don't need to have end-to-end connection from source to destination.
something like the IP for the
I'm not hearing you. Your line is
goes
breaking. You say? Hello? Your line is cracking.
Can you hear me?
I can. Your line is cracking. Maybe you should try to talk now. Let me see if I can hear you well. Can you say something now?
No.
Hello?
Hello. Okay, I'm saying something.
Okay, I can
Let
hear
me
you
try
now.
it another way.
Yeah.
Okay. You can hear me?
Nah.
Hello.
Hello? But can you hear me? Can you hear me?
No, can you hear me?
Um, I'm having echo.
I'll just type it.
Okay, just type. I think I heard you now clearly.
Okay.
Yes,
Oh,
I
you heard
can.
me now?
Yes, I can hear you now.
Okay. I was talking about the connectionless.
Yes,
Connectionless. You said the IP doesn't bother about the connection from the beginning to end about the end-to-end connection. The
yes.
IP just shows the path the message is supposed to pass through.
And TCP will do the
Is that
rest.
TCP is concerned about the end connection?
Yeah.
Okay. Okay, TCP carries the message, then
Yes.
IP shows the
Road to the
path the message is
destination.
supposed to
Yes,
go
the
to.
path to the destination. Yeah.
Okay, the path to the message.
Yeah.
Okay, that's fine, sir.
Yeah. So we're going to talk about TCP in the next when we get to layer 4. Because TCP is a protocol at layer 4. IP is a protocol at layer 3. We're going to talk about all of that. I'm going to summarize all the protocols you need to know at each of the layers before we finish. Okay, good. So I've explained most of these slides that I'm going to move through now my whole way. The network header, which is the same thing as our IP header, the source IP address is added, and the destination IP address is also added. And this is to help the message to get to destination. And this is how our packets, which is also IP packet at layer 3, looks like. This is the one concerned about the source IP address and destination IP address. There are other things we are not going to talk about, other feeds in the header, in the packet what do you call this, layer 3 header, which is the IP header. So but we are concerned about the address, the addressing, what do you call it, feed, address feed, they call it in the header. This is how the packet looks like. It simply means if I use Wireshark to capture this packet now at layer 3, when we get to cybersecurity, I'm going to be using more of Wireshark to show you some things. You are going to see source IP address. You are going to see destination IP address. Because if you happen to get hacked or attacked, you need to know where the attacker came from now. That's why it's difficult for hacker to how do we put it now? To deceive, let me say, the Americans or these developed country. They can tell you that these people that hack a particular organization came from North Korea, came from Iran, or came from Russia. Why? Because the source IP address does not change. So if I am able to see the IP address, I know where you came from. And that can be seen from the address feed of our packets, which we are going to use Wireshark to dissect when we come to cybersecurity. So that's that on the layer 3. So what's the summary of layer 3? The message is called packet at layer 3. That's the data. Source IP address is added. Destination IP address is added. So what is the IP address? What is IP in particular? IP simply means Internet Protocol. And that is only activated the moment you put IP address on a device. Now, maybe for your tablet or your phone that you are using to connect, you don't do anything. You just connect to your wireless network. The service provider must have configured their device in your house or in your office to give you IP address. If you don't have IP on your device, you cannot be part of the network because it's a major protocol that we use before we can send message from source to destination, and the protocol has to do with addressing. So when you get an address, that is activation of IP right there, and that is just what we need to know. So at layer 3, we talk about packet, we talk about IP address, source IP address, and destination IP address to help our message get to destination. So I want to move to transport layer now, and I don't know if you have any question before I move to transport layer. Okay, good. So transport layer is layer 4. So what happened at transport layer? I've already mentioned that at the initial stage, at transport layer, we call our data segments. We call our data segment, but a lot is happening here. Look at here. The transport layers moves data between application or devices in the network. So anything that has to do with the transportation of the message from source to destination, transport layer is the one in charge of that job. You need to know that. It moves data from source to destination. Okay, that's one. So what are the things that are happening, going to be happening at the transport layer? Now look at one of it. It tracks individual conversation. So whatever computer A is having or transaction is computer A is having with computer B, the transport layer is the one maintaining the conversation, as in tracking the conversation. But beyond that, this is the real thing that is doing though. Is segmenting data and reassembling segments and adds header information. What is the meaning of that? When you want to send data from source to destination, the data may be, let's say, 100 gig. You can't push this 100 gig of data at once. You may have to segment them, maybe 1 gig, 1 gig, 1 gig, for instance. If you can move 1 gig at a time, it is transport layer that will break the message into pieces and label them Segment 1, segment 2, segment 3, segment 4, segment 5, segment 6, and begin to move them on the network to the destination. And when they get to destination, it is the transport layer also that is also responsible for reassembling the segment. Oh yeah, where is the first segment? Where is the second segment? Where is the third segment? Where is the fourth segment? And hard up everything so that it cannot become readable to whoever is at the destination. That is why one of the things we just call our data at that layer, we call it segment. Because anything that has to do with segmentation take place at that layer. Anything that has to do with segmentation, it takes place at layer 4. Tracking of conversation take place at layer 4, end to end. But one more thing needs to happen here. We also have another header that is also handed. What is in the header? You know, we've talked about layer 2 header, layer 3 header. Now we are talking about layer 4 header. Another thing is also going to be handed in our message, and that is beyond the issue of segmentation, the issue of tracking of the individual conversation and stuff like that one. Header will be handed. Let me see if it's the next slide. Okay, let me finish it from here first. Header will be what will be handed: the source port number and destination port number. Source port number and destination port number. What is this source port number? What is it used for? What is the source port number used for? Let me show you something. Or let me explain something here. What is the source port number used for? Source port number. What is it used for? Destination port number. What is it used for? Port number, destination port number in particular. Let me explain that one first. It points to the services you are requesting for. Destination port numbers will point to the services you are requesting for. What is the meaning of that? Let's assume I am trying to browse the internet. We all know that browsing has to do with HTTP. That's why when you launch your browser, you are going to see HTTPS colon whack whack. Then you put the website. So if I'm trying to go to the internet, the computer or my layer 4 needs to be able to tell the routers where the service that I'm requesting for. And by that is going to add, let's say, port 80. This is a standard port. 80 has to do with browsing, which is HTTP. There's another port called 443. It has to do with browsing also, which is HTTPS. So in the message, beyond the layer 2 source MAC address, layer 2 addresses, beyond the layer 3 addresses, also we need to find out, or we need to know, we need to be able to point to the service that you are requesting for. So anytime somebody wants to go to the internet, in the destination port number, there will be a port number pointing to the service that you are requesting for. And the service you are requesting for, if it is internet, is port 80. Let's assume you are trying to download something from the internet. The port number you are referring to is 21. It's a standard port. We're going to see all the ports, some of the most popular. So in the destination port number, if we can capture that message and pieces it, we are going to see the service that you are requesting for. So port number is just to point to the service that you are requesting for. Destination port numbers in particular. So what happened to the source port number? The computer will just automatically generate any port number dynamically for itself, because it needs to have a source port number. But the real thing we need to see is the destination port number. So in the destination port number, when I capture your packet like this, I know the service you are requesting for. I know what you are trying to do on the net. If you are trying to surf the net, you are trying to browse, you are trying to telnet, you are trying to do remote login to a router or a switch or whatever, from your destination port number, I am aware of the service you are requesting for. I am aware of what you are trying to do on the net. So, and that also happens at layer 4. So layer 4 is doing a lot. Is doing segmentation, It's tracking the individual conversation. It's also handling the source port number and destination port number. The message is called segment and layer 4, and so on and so forth. Let me be sure you are clear with this explanation before I move on. Destination port number points to the service or the services you are requesting for. I'm going to take you back to my command prompt and show you, give you an example there when I'm done with this part. Good. Okay, this is very important. This particular diagram here, I just like the diagram. Very important. Very important. Now look at what I was trying to explain earlier. They say IP does not specify how delivery or transportation of the packet takes place. But who will do that job? Transport layer protocols specify how to transfer messages between hosts and are responsible for managing reliability requirement of a conversation. So which protocols are the ones that reside at that transport layer? The transport layer includes TCP and UDP. Now, this is why I say I like this now. Look at all the layers we've mentioned under TCP IP. Look at our network access, look at our internet layer, look at our transport layer, look at our application layer. The interaction of protocols that I explained in the second class, look at it at work here. How? Let's say I'm on the network here, I'm at LAN. I'm using a LAN technology. I'm at network access layer. Or let me say the message is at network access layer. I cannot do whatever I want to do on the net alone or the network alone. I have to rely on top of IP. IP is a layer 3 protocol. You can see it here. The most important protocol at layer 3. Then IP also cannot do its job alone. I should have started from home. Let's start from home, sorry. At the application layer where the user is, let's say I want to solve the net. This is me here now. I want to solve the net. The solving, the protocol that we point to solving is called HTTP. Now, let me explain it also. All these protocols you are looking at, FTP, HTTP, SMTP, DNS, CFTP, they are all referred to application layer protocols. Application layer protocols. Why are they called application layer protocols? Anything you are doing on the computer, as long as you're on the computer doing something, there is a protocol that governs what you are doing. There is a protocol behind what you are doing. So if, for instance, now you are surfing the net, the protocol that governs what you are doing is called HTTP or www. If you are sending mail, the protocol behind the mail is SMTP. If you are downloading something from the internet, the protocol behind download is FTP. These are just the most popular that we always use for to explain this thing. Okay? I was trying to explain DNS to you people in the last class. So DNS is also application layer protocols. But this is what I'm trying to say. All of these protocols, they can't do their work alone. They cannot be stand alone. They have to rely on top of some protocols at this transport layer. So now you are going to see what they did here. They put some protocols run on TCP, HTTP on TCP, SMTP on TCP. DNS can run on TCP or UDP. What is the meaning of that? What is the meaning of that? Now, anytime they put this, if they tell you that the protocol runs on top of TCP and application layer protocols, it simply means that protocols need acknowledgement. What is the meaning of that? Anything that has to do with TCP, it needs acknowledgement. What is acknowledgement? Nkechi, I've sent you $1 million. I have gotten it. You get back to me. I'm sending you another 10. I'm sending you $10 million. I've gotten it. You get back to me. I'm sending you another $1 million. I've gotten it. You get back to me. That is called acknowledgement. And because of the acknowledgement, TCP is reliable. That's why we say TCP is reliable. TCP is reliable. It's a protocol at transport layer. TCP is connection oriented because there is head-to-head connection. Because it's reliable, because it needs acknowledgement, or it works with acknowledgement. It's reliable because it's also end-to-end. It's also end-to-end connected, or we say it's end-to-end oriented, connection oriented rather. But look at UDP. UDP is also a protocol at the transport layer. Do you know the problem with UDP? Even though I don't want to say it's a problem, it does not care whether you get the money or you don't get the money. So UDP is a protocol and transport layer. So when I send you money, if my protocol I'm using runs on top of UDP, it will just send $1 million to you, and you will not get back to me to tell me if you got the money or you didn't get the money. So there are some protocols by standard. They were designed to work on TCP, and some were designed to run on top of UDP based on the way they've been designed and based on the needs of those application layer protocol. Take for instance voice. Voice. If voice runs on UDP, because they've decided that, or they've said that if we are going to be sending if we are going to be making call and be talking, acknowledgement will mess up our conversation. So we don't need the packet to be acknowledging me before I can continue talking. So they built that protocol on top of UDP. So this is a summary of what I'm trying to say. Some applications are built to use TCP. Some other applications are built to use UDP. So any application layer or an application that runs on TCP, it simply means it needs acknowledgement, is reliable, is connection oriented. And any application that runs on top of UDP is just the opposite of TCP. It's not reliable because it does not use acknowledgement and it's not connection oriented. So what I'm saying now in essence is that all these application layer protocol, they will either rely on TCP or rely on UDP based on design. But it doesn't matter whether you use TCP or you use UDP, all of you must rely on IP, which is a protocol at layer 3. And don't forget, all of these things happen concurrently. And that's when we talk about interaction of protocols. IP is working with TCP. TCP is working with FTP, depending on what you are doing. Or IP is working with UDP, and UDP and TFTP are working together. It depends on what you are doing. And that is why we refer to all of this as interaction of protocols. And guess what? Even the IP itself needs to rely on our local area network connection or on our wide area network connection. Because if you don't have physical connection, even if you are given static IP address on your phone or your tablet or wherever, it's useless. So you are always relying on something. So these are called interaction of protocols. So what is the take away from this particular slide? When I say internet layer protocols or network layer protocols, you should be able to tell me the protocols that operate at layer 3. These are not all, but this is the most important protocol. ICMP is also there. That is the one for pinging, for texting, for connectivity. HAP, that is Address Resolution Protocol, is also a protocol at layer 3. But the most important protocol that operates at layer 3 is your IP. The ones that operate at layer 4, they are TCP and UDP. And our application layer, there are thousands and thousands of protocols out there. But we only thought to use the ones that are very popular, which is our HTTP, FTP, SMTP. Anytime you send mail, this is the protocol that governs what you are doing. When you are browsing, this is the protocol. Of course, people use HTTPS right now. And when you are downloading, it's FTP. When your computer is changing a domain name to IP address, this is DNS. So you need to know all of these things. That's why I like this particular diagram. It just kind of summarizes the protocols for me. So when I say application layer protocols, you should mention FTP, HTTP, SMTP, DNS, TFTP, and of course HTTPS. These are protocols that operate at the application layers. Why? That is where you are as a user. You are there doing something. You are the one pointing to do so. You are trying to do something. And whatever you are trying to do, there's a protocol that governs what you are trying to do. Any question? Ikeji, are you still there or I'm alone?
I'm here. I'm very much here. No question. I am following. I understand it.
Good. You people didn't do OSR model in your course.
We didn't do what?
OSR model.
They were not so detailed as you are now. Okay, so it's more like you are explaining the things better for me. It's
Okay.
not something new. It's just it's becoming clearer, more like
Okay, good.
more
That's good.
detailed now. Yes, so I'm understanding it better now.
Okay. because you are going to be expert very soon in networking. So you need to know all these things.
Yes, I cannot wait. I'm willing to do the work. I'm ready, sir.
It's okay. So you need to, this is very important. This is very, I'm still going to send another set of videos that has to do with OSI model and TCP/IP model this weekend.
Oh,
Yeah,
okay,
apart
sir.
from the one with you people, I'm still going to send another one so that, well, after that, we're not going to talk about OSI model, TCP/IP model again. Okay. So we need to move. We still have
Okay.
one layer left, which is the application layer. Don't forget, we talk about physical layer, we talk about data link layer, we talk about network layer, which is also the same thing as internet layer of the TCP/IP model. We've talked about transport layer. Now we are going to go to the remaining three layers: session, presentation, and application layer. Okay. So for TCP, that is just a summary. It can acknowledge data. I've explained that. It can retransmit any unacknowledged data. If I send you $1 million right now and I don't get acknowledgement from you, I will resend again. That is the way TCP operates, so that there will be reliability. No data will be lost. That is the way TCP operate, and also send data at an efficient rate that is acceptable by the receiver. Because I'm going to talk to you, hey, Nkechi, I want to transmit this amount of data to you. How can you get it? 1 gig or 2 gig or 30 gig? We're going to discuss before I start sending all of these things to you. That is the behavior of TCP. Of course, I've told you UDP is connectionless. It doesn't have head-to-head connection. It's like IP, and it also does what is called best effort. They say I should give $1 million. If you get it, thank God. You don't get it, thank God. So there are some protocols that runs on UDP, and it works perfectly for those protocols. Like voice, I've told you, voice use what do you call it? It uses UDP. Why? Because voice needs to be fast. We don't want any overhead. What do you mean by overhead? If I say, Nkechi, I've sent you $1 million. When you reply back and say I got it, that's overhead. Extra message that is not necessary for voice. Okay, it does not require acknowledgement because it does not and it does not resend lost data. Deliver data as it arrives. So you need to understand. So some protocols run on UDP, some run on TCP, and I'm trying to explain all of those things in my whole way. So this is the summary. TCP can establish a session because it's connection oriented. It ensures reliable delivery, provides same order delivery, meaning if it segment 1, 2, 3, 4, 5, it will rearrange them and make sure that data does not arrive in the wrong order or they are not assembled in the wrong order. And it also supports flow control. So we can communicate, discuss on how to send the data to you and the rate at which you can get the message. So I don't overburden you with the quantity of data you cannot take per turn. And this is how a TCP header look like. What do we need to see in it? There's source port number and there's destination port number. That is the most important thing we need to look. There are other things there. We can see the sequence number. We can see the acknowledgement number in our TCP header. And these are the applications that uses TCP. I've mentioned that earlier. Your HTTP uses TCP, FTP, TCP, SMTP, TCP, SSH. What is SSH? I'm in Nigeria. I want to work on a router in London. I can have remote login. SSH gives me secure remote login into a device remotely to work on the device. But they all run on top of TCP. And of course, everybody must rely on IP. You cannot do it alone. Okay? Talking about UDP, it doesn't establish a session. It does not, it's not, what do you call it? It's not reliable because there is no acknowledgement. This data is reconstructed in the order that it is received. So UDP cannot do all the things that TCP is doing for us. It's just the opposite of TCP. And this is a UDP header. What is the difference? You only see source port number, destination port number. You're not going to see acknowledgement here. Like we saw acknowledgement in TCP. Let's go back to TCP header. You see? See TCP header here. This is the difference majorly. Acknowledgement feed, and then you can see sequence number feed. You are not going to see these two. When you capture a UDP packet, you only go to see the source port number and the destination port number, and nothing more. All the other things are not that important to us, except these two. Okay, so source port, they're telling us what is there, which is the source port number. Destination port number also, they're also telling us what is there, the length of the message, and we can check for error. So UDP also can check for error, and of course TCP also can check for error. Okay, so these are the applications that uses UDP. DHCP, you want to get an IP address, it runs on the UDP. DNS can use either UDP or TCP. FNMP, some of these protocols you don't know what they are, but we're going to come to the protocols later. This is voice, it runs on UDP. Video conference, it runs on UDP. And of course, everybody must depend on IP before they can do their job. Any question, please? Now, the next slide is application layer. Why will it just be application layer? Can you tell me why? Can you just try to figure out why we did not separate the, what do you call it, the remaining slides into a session layer, presentation layer, and stuff like that? Can you tell me why before I show you the answer? Okay, so you can try. Have you seen the answer? Hello?
Hello, sir.
Did you hear what I said?
You said I should tell you why we're not going to talk about session, presentation, like we went into details in the other one. Why we're just talking about application layer.
Yes.
Okay, although I'm looking at it now, I've not really understood the answer from here. But I wanted to just say because they're all lumped together, but then that's not a good answer
It
because the other ones
is.
we also
It
grouped
is
together.
because, see, look at what we are doing here. Because 3 layers of the OSI model have been bundled together to give us what?
The application layer.
Of the TCP/IP model. You need to
Yes.
you need to finish it that way.
Okay.
So because we don't have much to say about session layer and presentation layer. That is why when I was talking, I say the application layer, you call your data what? Data.
Data.
Then when it gets to layer 6, which is presenting, we still call it data.
Data.
At layer 5, we still call it data. Why?
Mm.
Not much has happened to the data. That's why we refer to data
Okay.
at layer 7, at layer 6, at layer 5. But the moment it gets to layer 4, we change the name to segment. Then here we change it to packet. A lot has happened, and so on and so forth. So because we
Frame.
don't have much going on as the presentation layer and session layer, we just decided to bundle them together and talk about the application layer of the TCP/IP model. Do you understand? We are still going to mention some things about those layers. Let's just move on.
Okay.
The upper 3 layers of the OSI model, look at them here. What did they define? They define function of the TCP/IP model. TCP/IP application layer, rather. That means all these layers of the OSI model, they've been bundled together into the application layer here. So what is the job of the application layer? Listen now. Listen and listen attentively. What is the job of this application layer? The application layers provides the interface between the applications used to communicate. The application layer provides the interface You want to go to Google. How do you go to Google? You launch a browser and you type www.google.com. That is an interface for you to hook up to Google. You want to go to Facebook, you launch a browser and type the website address of Facebook. That is an interface for you to hook up to Facebook, and you are just communicating with the application layer. So it provides the interface between applications used to communicate. So you are using your browser to access Facebook or access Google. That is the main thing that application layer is doing for us. Now they are talking of some of the most widely known application layer protocols. We've mentioned those protocols earlier: HTTP, FTP, TFTP, IMAP, and DNS. IMAP is also for sending of mails. So whatever you are doing on your browser, there is a protocol governing what you are doing, and that is why you have interaction of protocols. If you launch a browser now and you are trying to go to a particular website to go and download something from that website, by launching the browser and typing the website, that is port 80, that is HTTP or HTTPS. By the time you get to that destination and you click something to download, that is port 21. Excuse me. Sorry, this code is sorry, Nakodo.
Sorry, sir. No,
Thank you.
sorry, sir. It's okay.
Thanks. Sorry. So by the time you now try to download from that website, another protocol is in place to govern what you are about to do, which is file transfer protocol. You're
FTP.
about to start FTP. You're about to start downloading. So that's why this is sometimes it's not as if the HTTP will do so and go away. FTP will do sometimes they work together. So the job of application layer is to provide interface between the applications used to communicate. That is number one. What else can we learn here? They didn't tell us any other thing, but they now decided to say, okay, let's just tell you something about presentation layer. It has three primary functions. Number one, anything that has to do with formatting or presenting data at the source device into a compatible format for receipt by the destination, presentation layer is in charge. Compressing data in a way that can be decompressed, presentation layer is in charge. Encrypting data for transmission and decrypting data upon receipt, presentation layer is in charge. Let me give you an example. Your what do you call this? JPEG file, JPEG. Things that have to do with display of pictures, display of images, display of things and stuff like that. Well, look at them here. Look at them here. MKV, MPG, MOV, GIF, JPEG, and things that has to do with display majorly, formatting and displaying of things, or compressing things and decompressing things, or encrypting things and decrypting things. Presentation layer is the one doing that. So we don't say much about presentation layer. We just let you know that majorly it helps you with the presentation of, let's say, images, or compressing things and decompressing things. So you don't compress, and by the time you are decompressing, everything is scattered. No. Presentation layer will make sure that the way you compress from the source, you get it where you are decompressing it. It's presentation layer that is helping us to do that job. It's like event planner. They make sure things are in place when it comes to the way you put the image and the way the image is also gotten back. Okay. Now there's another layer there called session layer. The main job of session layer is to create and maintain dialogues between source and destination application. Create and maintain dialogues between source and destination application. Meaning my computer, if I'm on Facebook, there is a dialogue, is a session created. Session is like somebody watching, okay, he has talked, he's waiting for your reply. You have replied, you are waiting for your talk. You people started talking for so time. Are you trying to finish your talk, or have you finished your talk? And some just to keep the communication line open. I think that's the best way I will put it. Session layer is the one that is handling that. So it keeps the communication Okay, they didn't talk about it here. It keeps the communication line open between the two devices talking. And don't ever forget this. There is no distance in the spirit and so also in the IT field or in networking. If I'm in Google from just here, it doesn't matter where that server is located in the world, I'm in. And my computer has created a session. So session layer is monitoring head-to-head communication between my computer and the dialogue, let me put it that way, between my computer and the server that I'm talking to, or the destination computer that I am talking to. So we don't have much to say about session presentation layer and session layer. This is just a summary of what they do. That's why they are not that popular when we are talking about the layers. We don't really deal with them as in one after the other, but like the other layers we've talked about. Okay, so still talking about the application layer protocols, I've mentioned them earlier, and we're still going to come to them. But don't ever forget your HTTP, HTTPS, FTP, Telnet, SSL. You need to know all the popular protocols that operate at layer 7, and the ones that operate at layer 4, and the ones that operate at layer 3. And that's why I said I like this particular diagram here. It just kind of summarizes everything for me. Where is that diagram? This one here summarizes everything for me. You know, didn't put everything. SSH is missing here. SSH. Telnet also is here. And we're going to talk about all these things later. Learn how to use Telnet, learn how to use SSH, and so on and so forth. Okay. I think that's the last slide. Okay, that's the last slide. So we've talked about the TCP IP application layer protocols. These are very important. And why are they important? You get to understand better by and by as we move on. You'll see if somebody is trying to do, or somebody has done something on your network and you are trying to analyze, application layer can give you some information. TCP transport layer can give you some information. Layer 3 can give you some information when we capture the package. That is some of the reason why cybersecurity analysts are they are popular, because they can analyze the package, they can analyze the message. These are some of the things you capture from the message for you to be able to give informed, to make informed decision about what is going on your network. So that will be it. Any question?
Sir, on the last slide,
Okay.
I don't know what that is. You just show me the last slide. Okay, where you have this okay, this is DHCP, the host configuration.
DHCP.
What's that client 68? What's that client stand for? Yeah,
Okay.
under here, yeah, this client
I'm going
68
to
is
talk
also
about,
the
let me
client.
just talk about them briefly, but I will still talk about them again. Now,
Okay.
those protocols, the application layer protocols, I say they have port numbers. I say like HTTP is port 80,
Port 80.
HTTPS is port
Okay.
443, and we also use for 83, 8080 rather. Now for
As port
DNS,
number 2.
sorry, 8080.
It's just a port number. I know about the port number, but I know that HTTPS is port 80, but I don't know this 8080. Is it also the port number 2?
Yes, 8080 is a port number 2 for HTTP.
Okay.
Yes, for HTTP. But do you
Okay.
know the one for a DNS?
No, I don't know. I
Okay,
just know about this
DNS
one
is port
because
53.
oh, okay. This client 53 is
Yes.
also number.
Yes, it's
Okay.
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 You remember this what I said, but okay, let me just use the
Mm,
DHCP to finish this, to explain this thing.
mm.
Sorry, something is blocking my screen. I need to get rid of it. Call me. Call me just a minute. Something is blocking my.
Okay, sir.
Okay, can you see my screen now?
Yes, I can see it.
Okay, now look at what we're saying here. You can see UDP client 68.
Yes.
Then you can see server 67. What is
Yes.
DHCP? DHCP simply means Dynamic Host Configuration Protocol. That is what we
Okay.
use to give computer IP addresses automatically. Okay, on your network, wherever you are now, maybe you are at home, you connected through the wireless, right? If you check,
Yes.
by the time we come to IP addresses, you will be able to check the IP address that you were given without you doing anything. That
Okay.
means you go to IP address automatically. It's because this particular protocol has been configured on your device.
Okay.
Now, this is what happens when a client is requesting for DHCP, that is IP address, eh,
Mm.
is going to request with the source port number of 68 and point to port number of 67. Meaning what? I'm a DHCP client. DHCP client. I'm coming with port 68. I'm looking for a DHCP server. What is the service we are both reporting to? We are pointing to DHCP. So 68 is used by the client and the server is using 67. But both ports are used for DHCP.
Okay.
So those application
Okay.
layers protocols you saw, all of them have port numbers. Let me go back again and show you something. Okay, look at. There's one okay, I think it's this one. Yeah, like this one now. SSH. I explained SSH. I didn't mention the port number. SSH is port
Mm.
22.
Okay.
You get my point. So let's assume now
Yes.
on your router now, you don't want somebody to be able to SSH into your router. You go and block port 22. You filter that port
Oh.
number. So if you filter that port number, it simply means I cannot have a remote access to your router.
Okay.
So if for any reason you are trying to analyze the messages on your router through the logs or Wireshark, and you saw that somebody came in with port 22, you already know that somebody did a remote login, had a remote login to your router. So we know what
Yeah.
the protocol is doing, and we know when we see the port number, we know what the port number is attached, the service that is attached to. So all the application layer protocols I mentioned, they have port numbers. This one I can't remember the port number, and I have not explained it to you. It's for managing of devices on your network. Okay, like FTP now is port 21. If I'm trying to analyze some data right now and I see 21, I know somebody has downloaded something from that network. So I can now begin to narrow down who did what, for which IP address, for which MAC address. Then we'll lock down, we know who did, what do you call it, who downloaded on the network. So all of this is we are talking
Okay.
about, they are going to help us to do our job later when we come to cybersecurity.
Okay, sir.
Yeah.
Okay, sir.
Any other question?
No, no other question for now.
Okay, good. So you see,
Please, sir, can you send me the recording also?
I will. I will send it on
Mm.
the WhatsApp group now
Yeah, in the chat. Yes.
because of faith.
Faith.
Yeah,
Mm.
yeah,
Okay, you
okay,
wanted to say something, sir?
yeah. So, okay, I was going to pull your legs now. You were scared of the class being 3 hours. Now I've not even spent 2 hours now.
No, because it's something new,
Yeah.
and I wasn't